And now we move on to 9, part B of the same question. We have another sequence, S1, S2, S3, S4, S5, and so on. 1 times 1, and 1 times 2, plus 2 times 1, plus 1 times 3, plus 2 times 2, plus 3 times 1, and so on. And they give you the value of each of the numbers in the sequence. And they told us to work out the next term in the sequence. Now, there's 2 ways we could do this. One would be longer, actually. But I'm going to show you both of those ways. Okay? One of the ways of doing this would be to just carry on the sequence as we see it in the row. So you say, okay, it's like 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5. This must be 1 times 6. And you can see that you have to add to that. In this case, the first number goes up by 1 each time. So it's like 1, 2, 3, 4, 5. So this is going to be 2. And then you're going to have 3. Then you're going to have 4. Then you're going to have 5. And then you're going to have 6. It stops at 6, which is the same number that's over here, you see? So that'll be 1 times 6 and 2 times 5. So this number goes up and this one goes down. 3 times 4, and 4 times 3, and 5 times 2, and then 6 times 1. Okay, and if you continue that, if you do that, it's going to be 6 plus 10 plus 12 plus another 12 plus 10 plus 6. So you end up with 2 12s, this is 24, well in fact 3 12s, 36 plus 20, that's 56. Okay, so the answer is 56. Now that's a long way of going about it. There's actually a shorter way. We can just use this pattern here. Okay, from 1 to 4 we've got to go up by 3. From 4 to 10 we've got to go up by 6. From 10 to 20 we've got to go up by 10. From 20 to 35 we go up by 15. So the amount that we go up by each time is increasing. That's going up by 3, and that's going up by 4, that's going up by 5. The next one must go up by 6, it must go up by 21. So we have 35 plus 21, 35 plus 21, which gives us 56 as we write it down. Okay? Alright, and part 2 of B says the formula for the nth term of the sequence is given by Sn equals 1/6 times n plus 1 times n plus 2. Says show that this is true for n equals 6, so we should get 56 basically. If it equals 56, then we know that this sequence is true because that's what we got. This is our S6 here is equal to 56 in part 1, which we found by actually continuing the sequence. So let's see if it works, this formula. So S6 is equal to 1 over 6 times 6 times 7, and then times 6 plus 1, 6 plus 2, which is 8. Okay, 6 times 7 times 8. So we're going to have 6 cancels out with 6, leaving you with 1, 1. And 7 times 8, which you should know in your times table, is 56. So therefore, it's true. Okay? All right. Now, part 3. It says find 1 times 20 plus 2 times 19 plus 3 times 18 plus all the way to 20 times 1. So basically it's the same sequence if you look above. It's just that our n is going to be 20 this time. It's going to be 1 times 20 plus 2 times 19 plus 3 times 18 all the way back to 1 again. So it's basically, this is the same sequence, all right, that we're going to use. We're going to say Sn equals 1 over 6 times n plus 1 times n plus 2, and our n has to be 20. So we say S20 equals 1 over 6 times 20 times 21 times 22. Now the 6 cancels with the 20, leaving you with a 10 and 3. 3 cancels with the 21, leaving you with a 7. So you end up with 70 times 22. Okay, 70 times 22. Okay, that gives us 1,540. So 1,540 is the answer for part 3. Okay? Now, I'll move on in the next video to part